In this lesson, you will learn how to solve similar figures. Similar figures have corresponding sides that are proportional and corresponding angles that are congruent. Let's look at our first example. We're going to find the missing side, CB. These triangles are similar. We can see by angle, similarity, these are similar figures. So we're able to solve for the missing side, CB. We'll label that as an X. So the corresponding sides are proportional when these figures are similar. So X over 10.2 will be equal to, come back to your first triangle. If you started with that first triangle, you need to come back to the first triangle, and 7.5 over 15. Set up the proportion in order to solve. We cross multiply, so we get 15x equals whatever 10.2 times 7.5 would be. 10.2 times 7.5 gives us 76.5. So we have 15x equals 76.5 when you cross multiply. You then are going to divide by 15. So x is going to equal 5.1. So that was the missing side that we were asked for, CB equals 5.1. Let's look at number 2. We're going to find the missing side, DE. So here's our missing side. Label it at X or whatever variable you would like to use. We can say that these triangles are similar by side, angle, side. We're given two pairs of sides with an included angle between them. So side, angle, side shows us that they are similar triangles. So we're able to use that knowing that they're similar to be able to solve for the missing side. So X is our missing side. It corresponds to BA, so that's the 5.2. And then just pick another pair of sides. So it doesn't matter if you want to go with CD or even CE. But again, remember to come back to the triangle you started with. Since our variable X is in this right side of the, or in this right triangle, we need to come back here for the numerator of our next fraction. So let's go with the 5.6. That side, since it's the shorter of the sides, we'll go with the 3.5. Be very careful when setting up your ratios that you set up the corresponding sides with one another. Cross multiply, so we get 3.5x equals 5.2 times 5.6. So 5.2 times 5.6 gives us 29.12. You'll divide by 3.5 on both sides. So that gives us, for x, dividing by 3.5 gives us 8.32. So for DE, we found it to be equal to 8.32. Of course, you could always set that up with the corresponding sides to see that it is actually proportional with the other sides that were already given. Let's look at another pair of figures. This time we're working with some quadrilaterals. It did tell us that they were similar, so we can find that missing side by still the corresponding sides would be proportional. So X is going to correspond with, we are missing our letters. Let's look back at this. We have, this figure should be A, B, C, D. And this one is Q, T, S, and R. So now we can see TS, in our statement here, they said TS goes with DC. So that side is the 91. So coming back over here to this figure that we started with the unknown side, just pick any other side that you like. You can go with the biggest number, the smallest number, the kind of number in between. I'm going to go with the smallest number. So I'm going to say 3 over So QT, if you look back at your similarity statement, QT has to line up with AD. So AD is 21. And then you cross multiply to solve. So 21x equals 91 times 3 gives us 273. Divide both sides by 21. Dividing by 21 gives us x equals 13 for that missing side. You would have gotten that same solution even if you picked another pair of corresponding sides. So if you wanted to pick this RS, looking at our similarity statement, would go with BC, so you would write it with the 28. So again, you could have replaced this ratio that we chose with a different pair and still solved to be the same value for the missing side. Another theorem that uses similarity proportions is the triangle proportionality theorem. It says that if a line parallel to the side of a triangle intersects the other two sides, then it divides those sides proportionally. So pretty much if we have our triangle and we have a line cutting the sides of the triangle, and that line is parallel to one of the sides, then it is going to be proportional when solving for your missing side, or really missing piece of a side. So let's look at example 4. We're going to find Pn, so let's label that as x or whatever variable you want to use. So using this triangle proportionality theorem, we can start with our missing side. And it says that if we have that missing side, it is proportional to the other pieces of the missing side. So x to 3, come over, since we started in this part of the triangle, we have to come back down here to the 5 and pair that up with the 2. Just make sure your corresponding pieces this time, since we have that parallel line dividing the triangle, that your pieces of your triangle are all set up in corresponding. You're not allowed to go x to 3 and then your next fraction be 2 to 5. It does have to be corresponding parts. So x goes with the 5, 3 goes with the 2. So we set that up in our ratio. Cross multiply, so we get 2x equals 15. When you divide by 2, we solve for that missing piece. So 15 divided by 2 gives us 7.5. So we were asked to find Pn, and that is 7.5. Let's look at number 5. Notice in this one we do have that line that is parallel to one side of the triangle. But when they cut that triangle with that line, they didn't give us the value of the piece, they gave us the whole value of the whole triangle. So if we know this whole piece right here is 13, we can find this little piece by a simple subtraction. Just take 13 minus 5 to get 8, because you'll need to know that little piece in order to set up your ratios. Rn is what we're trying to find, so that's your variable x. It is my preference to start with that missing piece, so x is going to correspond with the 10, and then go back to that. If we're on the kind of bottom right, we now need to go to the top right kind of piece of the triangle, so 5 with the 8. Be very careful. X with the 10, go back, and we have 5 with the 8. You're not allowed to say x with the 10 and then 8 over 5. That would not have the corresponding pieces together. So cross multiply, we get 8x equals 50. When we divide by 8, it gives us 50 divided by 8, which is 6.25. So for Rn, we have 6.25. Let's look at our last example here. Notice we're asked to find JU. But JU is not just going to be represented by x. It's represented by this -4 plus 4x. So we're going to have to solve for x, but then go back and plug it in order to actually find the missing length, JU. Well, let's start with that piece, -4. -4 plus 4x. And we're going to set that up with 40 as our ratio. And it's going to equal, come back and get the 27 over 45. Again, always being careful that your corresponding parts are set up in your proportion correctly. When you cross multiply, be careful that 45 needs to be multiplied times this whole thing, -4 plus 4x. So you might want to take the step of writing 45 times that whole thing so that you can see that it is going to use the distributive property. You can go ahead and calculate 40 times 27. 40 times 27, we get 1,080. Distribute your 45, so this will give us 45 times -4 is -180, and then we'll also do 45 times +4, which is, of course, +180. So we have -180 plus +180x equals 1,080. We now need to solve this by adding 180 to both sides. So we get 180x equals 1,210. So let's do the 1,080 plus 180. So 1,260. When you divide by 180, notice that we're only solving for x once you divide by 180. That gives us 7. We are not done. We cannot say that JU equals 7 because JU was represented by this -4 plus 4x. So go back. JU is going to be -4 plus 4 times, plug in that 7. So -4 plus 4 times 7. 4 plus 4 times 7 gives us 24. So the length of that side that it asked for JU is going to be 24.